Greetings. Let's continue our previous lecture. So, in our previous lecture, we discussed some theoretical background behind this network or circuit, and we also understood that circuit is a subset of network. Otherwise, we can use these two words, network and circuits, interchangeably. Okay. So in this lecture, we try to analyze this circuit or network like this. See, you have couple of sources. You have two active sources, 5 volt and 10 volt, with respect to polarity. Okay, so polarity is like this. Okay, and also in the intermediate zone you have a passive element resistor whose value is 5 ohms. See, passive element, in this case passive element, what it does, passive, the meaning of passive is it consumes energy or it consumes power. Yeah, see the and also passive value is always positive. For example, you see, whenever we say passive quantity, passive is always consuming or absorbing, so consuming energy or power. Yeah, so consuming energy, or you can say power, or absorbing something. And this fellow, this resistor, he cannot accommodate any energy. The moment he receives some energy, in no time this fellow will dissipate out or in the ambience. Okay, and also if you observe carefully, everywhere, anywhere you see R value or L or C value, all these three components are passive components, and always we see they are positive. Yeah, all passive elements have positive values. See, did you ever see like this here? For example, say R is equal to 1 kilo ohm. A German scientist, Simon Ohm, R equal to 1 kilo ohm. Now, nowhere we see R equal to negative 1 kilo ohm or negative 1 mega ohm or negative 100 ohms. Yeah, or some negative 33.3 kilo ohm, like that. So R, L, C, always we see them as positive values. The meaning of positive is they are passive. That means R and C components, they cannot generate energy, or they are not the cause, they are not the causes behind energy. Okay, so anyways, so the meaning of passive is they don't generate any energy, they simply absorb, they simply consume, or they simply dissipate. Okay, so unlike resistor, L and C, what it does, L and C is also passive element, and also their values will be again positive. For example, say 1 Henry or 1 microfarad, that means positive 2, I mean positive, say positive 2 millihenry, or some 0.1 nanofarad, something like that. But they see, in this case they are passive, but they store energy, right? They store energy. Now they store energy only in the presence of active sources. Yeah, so we will go in detail about these passive elements and active sources and their physical insights and mathematical stuff behind that, and all those things. We have many more lectures queuing up, and we will unlock many more things. Okay, for now we know very well both, I mean both R or R, L and C, all these three are passive components. R cannot store any energy, L and C can store energy, and this is possible only in the presence of active sources, either current source or voltage source. In the absence of current and voltage source, hardly L and C can store any energy. Yeah, this point should be noted down. Yeah, this is very, very important. And again, in the presence of, say, active source, for example, in the presence of active source, say for example I have some source here, say I have some source, I have some source here, and say you have R and say L. Let me take unpolarized capacitor. So unpolarized capacitor means polarity doesn't matter. Okay, polarity doesn't matter for unpolarized capacitor. So anyways, say you have RLC components. Now in the presence of this source, this network gets energized. So this network gets energized in the presence of this source. Okay, so the moment we connect source like this, the moment we connect source to this network, so these elements will absorb energy from this source. So this fellow will absorb energy, and in no time he will try to dissipate to its ambience, to its surroundings in the form of heat. Okay, but these two fellows will try to store energy from this source. Yeah, that means source is the cause of energy transfer. So that energy will be that energy will be stored in both L and C, and energy will be stored in the magnetic field in this case, and energy will be stored here in the electrostatics field in this case. Okay, so what happens say after some time, say after delta t, delta t means some very small time, say after delta t seconds. Suppose if you remove this source, say you remove this source from this network, then what happens? Yeah, then in that case, whatever energy got stored in LNC, that energy will be given out. And or that stuff will be given out through this resistor. Yeah, see, in either case, resistor will simply take something and will always give it out. Okay, so we will see only in that case current will go from minus to plus through C and L, but in that case also current always go from plus to minus through R. Alright, always current always flow from positive terminal to a positive quantity to negative quantity always. Okay, current always go like that. Yeah, so but only in the absence of source, current may go from negative to positive through C and L, but in that case even current always go from plus to minus through R. Okay, so we will try to investigate details of this in our subsequent lectures. I'm just giving you a glimpse of this networks or circuit analysis. Okay, let's back to this problem. Say you have two sources, we have two DC sources here and one passive component we have. If this is not really mentioned, the direction of current like this, as mentioned like this, so if it is not really mentioned this way, or you can take this way, doesn't matter. Now the question is, find say current through 5 ohms. If question is this, find current through 5 ohms. So I will give you options here. So you see, options may be like this. Options may be say 1 ampere, and current has units of amperes, right? Ampere. So option B 2 ampere. Say option C is 3 ampere, and option D is say let's take none. We often struggle selecting 1 out of 4, but if you go to IES, you will get a very big blow sometimes, because sometimes in IES he may also give us 5th option. Okay, so the 5th option we will see. The 5th option we will see now anyways. Whether or not we have 5th option here we will see, or we go for none, whatever, or 3, 2, 1, whatever, doesn't matter. Okay, so we will try to find this. So in no time, so most of us what we think that, if you are lovers of superposition theorem, so if you like superposition theorem, so definitely without seeing its details, because of 5 volt Yeah, 5 volt will appear across this. So 5 by 5, 1 ampere will go through this 5 ohms. Yes or not? And if you close this source, because of this 10 volt, now what happens? 10 by 5, because say I is equal to, say I, my markers are not running well. So I is equal to, say V over R, I equal to this. One of the forms of Ohm's law. Okay, Ohm's law means not only V equal to IR or V equal to RI, V equal to L di by dt is also Ohm law. Yeah, Ci is equal to C dV by dt, or V is equal to 1 by C integration of I dt is also Ohm law. J is equal to sigma E is also Ohm law. So J is equal to sigma E is, you know, Ohm's law when you go to field theory. Okay, in circuit theory we don't take J is equal to sigma E into account. Anyways, like circuit is subset of network theory or circuit theory or network analysis or circuit analysis is subset of field theory. Okay, field theory is like father and mother, the circuit theory is like chotu kids. Okay, so anyways, at really very high frequencies, Kirchoffs current law and Kirchoffs voltage law will just violate just like that. Okay, because Ohm's law plus KCL, Ohm's law plus KVL is really acceptable. Okay, if KVL or KCL violates, then entire stuff will violate. At low frequencies or high frequencies, we can deal anything using field theory. So also we have lectures on field theory, electromagnetic waves, okay, and also we have lectures on antenna analysis, and also we will do lectures on electronic devices, signal systems, signal processing, communications. I'm listing out all subjects, right? But eventually things will turn out. Don't worry. Only intention is to make quality stuff, nothing else out of anything. Okay. So again we are intervening in our problems many times. So now at this juncture, many of us will go for 3 amperes if you love superposition theorem. Yes or not? So current due to 5 volt alone, by forgetting remaining things, we have say 1 ampere. Current due to 10 volt alone, you have again 2 amperes. So superposition means what here? Just add these two stuff. 1 plus 2 is 3. Okay. So see, options are given something like this. But in reality, what is the answer for this? Now find current through 5 ohms. Find current through 5 ohms. So how do you tackle this one? How do you tackle this? Let me put one more. So okay, so how do you tackle this? Let me redraw this. Let me redraw my circuit. I have a passive 5 ohms and 10 volt, and here you have 5 volt. Okay, 5 volt, 10 volt. Let's say you have connecting wires. Okay, and interestingly we are going to compute this. Now say current through 5 ohms. So we wrote this, I think this is third time, right? But please do accept, we often go back and forth. Yeah, just to make things clear. Okay, anyways, let me change my marker from blue to black. And okay, the same circuit can be redrawn like this, or the same circuit is identical to this. Okay, so this is 5 volt and this is 10 volt. Doesn't matter, right? However we connect, because all three components they are in shunt, they are in parallel. Again, in literature, shunt and parallel, they are not exactly same. Yeah. In English terminology, shunt means bifurcation or dividing. Yeah. So, anyways, we'll go for that later. Here you have 5 ohms for this. Okay. So now you see, now within a loop, this is a loop, right? This is loop 1, this is loop 2, and this entire stuff is say loop 3. I can go anyways. So as of now I can see 2 loops, loop 1 and loop 2. Now I take current like this. This is say I. Okay. Either I can take clockwise or anti-clockwise, doesn't matter. End of the day, KVL must get satisfied within a loop. Okay. So what is KVL here? Conservation of energy in a loop. Yeah, sum of drops must be equal to sum of EMF quantities. Yeah, sum of rise quantities must be equal to sum of drop quantities. Say now current is taking current is taking say clockwise journey. So this is negative. I have negative here and positive. Now as the stuff is moving clockwise, now when we are moving from minus to plus, negative to positive, say you're achieving something, you're going from minus to plus, achieving something, say that is positive 5 volt. Okay, and again here we have plus and this is minus. So in the same clockwise journey for current, now current encounters positive first, then exiting at negative quantity here. So therefore current is entering from plus to minus. That means you are losing something, say minus 10. So again, same, end of the day, this left hand side, whatever drops or whatever you have must be equal to say EMF or something, or rise, whatever. So sum of the voltages in a loop, sum of the voltages, so left hand side can be sum of rise or rise and drop. So that sum must be equal to 0. So unfortunately what happened here? So negative 5 equal to 0. So see, 0 is something like dump. So I can throw this negative sign over here. So 5 equal to 0. Now what is the meaning of this? Or I can take this one, doesn't matter anything. I can take this or this one. But what is the meaning of this? The meaning is 5 equal to 0 indicates that someone is giving something. Someone is giving energy. Someone is giving energy, but nobody is taking that energy. Someone is giving energy and no one is taking that energy, then what happens? Yeah, someone is giving electrical energy and no one is taking that electrical energy. Then what happened to that energy? That electrical energy got converted to heat energy. Yeah, and some other a part of energy quantities, whatever. So again, this must be because conservation of energy must get hold or must get satisfied everywhere. But if you forget about heat energy and this electrical energy, 5 equal to 0 is highly impossible, right? This is highly impossible. Someone is giving something, no one is taking that. Finally what happens? Violation of KVL. So this says that violation of KVL. So gone. Now what you do? So violation of KVL. Now how do you conclude? Yeah. So how do you conclude now? I am scratching my head how to conclude. Okay. Now any guesses? Any idea? Any idea? Any idea means which option is the correct one. Okay. So 1 ampere. This is impossible. 2 is again impossible. Is 3 okay? 3 is impossible. And none. Okay. If I don't know anything, I'll go for none. Anyways. But sometimes you must have guts to write something new. Okay. So you must be able to write something here like invalid circuit. So you cannot connect a circuit like that. You cannot connect a circuit where violation of KVL or KCL happens. Never. So KVL and KCL should not violate. Yeah, of course. So you have to see to that in every circuit design, this Kirchoff laws must hold good always. Okay, so the final answer for this question is invalid circuit. So what do you conclude from this? What do you conclude from this? The conclusion is very straightforward. See, from every circuit, you must be able to conclude something. In this case, the conclusion is yes, sorry. Conclusion is what? This is my passive component. So across a passive component, no two different voltages can act. All this happened because what? This 5 and 10, they are unequal. Yeah, so across this passive component, no two different voltages can act. You cannot connect like that. You cannot really connect two different voltage sources in shunt like this. This is a very simple and interesting and most required observations. Okay, so across a passive component, never, this will never happen, right? Across a passive component, no two different voltages can act. No two different voltages can act or can appear. Yeah, this is very important. You cannot connect two different voltage sources in shunt or in parallel. Okay, so now this is what conclusion from this. So finally you have drawn this conclusion. Yeah, now I'm somewhat okay. I'm not really happy, but I'm somewhat okay now. Okay, so I'm neither smiling nor crying. Now now we will take one more step forward. We'll take one more step further. Now we are going to knuckle down. Let's knuckle down into other issue like this. Let's take similar kind of issue. Say you have say 5 ohms. On one end of this you have say 10 volt. Okay, on the other end say you have again 10 volt. Okay, all right. Now again, if someone is asking you find current through this 5 ohms, again if someone is asking this, find current through 5 ohms. Okay, so how do you find this? Now across a passive component, no two different voltages can act. Okay, see in this, let me go to my previous slide. Okay, previous page. I'm not using any slides. I'm using physical quantity. See, this paper is a plane here. This paper is not a plane because a plane will never have finite boundaries. Yeah, a plane will always have infinite boundaries, infinite extent. So a finite piece like this cannot be a plane, but we approximate this as a plane. Okay, back to this again. So the conclusion what we have drawn is this. Across a passive component, no two stuffs can act like this. Yeah, so now we are so happy, and you have like this. So do you think current through 5 ohms is 2 amperes? If I give you options like this, option A 2 ampere, say option B negative 2 ampere. Now there is again a discrepancy here between positive 2 and negative 2. It depends upon the direction of current we choose. Okay, so C is say 5 amperes and it is none. Yeah. Okay, sometimes we must have again guts to choose option E if you have. Okay. Now, in this case, you have same voltage sources. So we will check it like this. So this above circuit is identical to this. So I can redraw above circuit like this. Okay, so this is 10 volt, and again you have 10 volt here, and now this is 5 ohms. Let me take my blue. Now I have here, say, 2 loops I have here. Now in every loop again KVL must satisfy. So again I take, this conventional direction, that is, say, clockwise like this. This is my I. So this is what terminal here, positive, negative. This is positive, negative. I am moving from positive to negative. So I am moving from positive to negative means losing something, think like that. So losing something is, say, minus 10 volts. Okay, and now I'm coming all the way, and now I'm moving from positive to negative. So again I am losing stuff, or again say minus 10. So this must be equal to 0. Yeah. So again, unfortunately, in the initial run we saw two same, we felt very happy that we're in safe zone, but please do compute for further steps. Now we got minus 20 volt equal to 0, or this is, say, 20 equal to 0. Is it possible here? Now someone is giving very big energy and no one is taking that. That means you can use these kind of circuits only in Diwali. Yeah, if you want to crack something, then you can use this kind of circuits in Diwali, and a lot of heat get generated. As these two are two sources, you don't get that heat. If you take really big DC voltage sources here, you get a lot of heat from this, and that leads to a great damage. Okay, so again, violation of KVL. Violation of KVL. Now really, what is this? This is really horrible, right? Now I have to scratch my head using both hands now. Yeah, I have to scratch like this. Really, what is this? Just now we understood that across a passive component, no two different sources can act. That means same stuff must act across a passive component, and we have same stuff. But what happened? Yeah, what happened? Of course, you have same stuff, but what is the difference here is that polarity. Yeah, same stuff is there, but polarity got reversed. I have negative positive, and I have positive negative here. Yeah, and due to this, this leads to this destruction. Yeah, this damage is because of this polarity mismatch like this. So therefore we must be able to add. This. Okay, that is this. So across a passive component, no two different voltages can appear. That means across a passive component, if at all there is a situation, so across a passive component, same voltage sources must act. Same voltage sources or same voltage stuff must act, and also with same polarity, This is the final conclusion. Okay, so this is my final conclusion. Oh my god, this battery is getting down, sorry. Okay, so this is my final conclusion. Okay, now it's time to Now it's time to chill out. Yeah, I got to my final conclusion. Okay, thank you for watching this. So please note down this final conclusion. Yeah, any comments, any positive or whatever comments, please feel free sharing those comments in our comment section. So bye.